Welcome to Session 7, Composite Area. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to decompose an irregular figure into non-overlapping familiar shapes. Decide whether joined regions should be added or removed regions subtracted. Infer missing segment lengths from the full width or height. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The composite figure can ask for boundary length instead of area. The rectangles are useful building blocks for decomposing a figure. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here is the central reasoning. For an L-shaped floor, one valid plan may be a large 10 times 8 rectangle minus a 4 times 3 corner. Another plan may split the L into two rectangles. Both must give 80 minus 12 equals 68 square units. A composite figure has more than one valid decomposition. Adding pieces and subtracting a cutout must agree. Comparing the two approaches is a powerful verification strategy. Estimate with a nearby rectangle or familiar benchmark. The estimate does not replace the exact calculation. It tells you whether the exact result belongs in the right neighborhood. Now add a precision check. For every area or boundary problem, identify exactly which segments form the base, height, radius, diameter, or outside edge. Convert units before combining measurements, keep full precision during the calculation, and round only once at the end if the context requests a decimal result. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, draw cut lines that create rectangles, triangles, or circles with known formulas. Second, label every needed dimension using subtraction to find any missing length. Third, compute each piece separately and keep square units on every subtotal. Finally, add included pieces or subtract holes, then compare with the area of a bounding rectangle. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A floor with a rectangular rug already covered has outside dimensions 20 by 12. The removed rectangle is 6 by 5. What area remains? Step 1 is to organize the information. Draw cut lines that create rectangles, triangles, or circles with known formulas. Step 2 chooses and sets up the relationship. Label every needed dimension using subtraction to find any missing length. Step 3 carries out the mathematics. Find the whole area and subtract the removed part. 20 times 12 minus 6 times 5 equals 240 minus 30 equals 210. A useful check is to cut out, removed, or not painted means subtract. The answer is 210. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it's your turn. A field with a shed footprint removed has outside dimensions 16 by 15. The removed rectangle is 8 by 4. What area remains? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 208. Find the whole area and subtract the removed part. 16 times 15 minus 8 times 4 equals 240 minus 32 equals 208. A useful check is to cut out, removed, or not painted means subtract. Use this coaching check as well. Use 2 decompositions as a self-check when the figure is complex. Matching totals are strong evidence that no piece was missed or counted twice. Session recap. First, draw cut lines that create rectangles, triangles, or circles with known formulas. Next, label every needed dimension using subtraction to find any missing length. Then, compute each piece separately and keep square units on every subtotal. Finally, add included pieces or subtract holes, then compare with the area of a bounding rectangle. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.